Good morning, Mr. Ahmed here. Goal for today is to use the discriminant inside of the quadratic formula. So if we think back to what the quadratic formula was, the quadratic formula was x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That was how we used the quadratic formula. The discriminant is what's inside of the square root, or inside the radical. The discriminant is b squared minus 4ac, okay? The reason why this is helpful for us, if this value is positive, b squared minus 4ac, that means there's two solutions, okay? If this value is negative, we couldn't take the square root of a negative, therefore there are no solutions. And if it's 0, there's only one solution. So that's kind of what these graphs here look like. If b squared minus 4ac is greater than 0, that means it is positive. That means it crosses the x-axis twice. There's two solutions where it crosses. If b squared minus 4ac is equal to 0, that means the parabola only touches the x-axis once. There's one solution. And if it is less than 0, that means it is negative. If b squared minus 4ac is negative, that means there's no solutions. The graph would never cross the x-axis, okay? So we have three possibilities with the discriminant. We are going to put it into standard form. After we put it into standard form, we'll calculate b squared minus 4ac, and then we will determine how many solutions that the quadratic equation would have. So our first example says negative x squared plus 4x minus 4. It's already in standard form. So a is equal to negative 1, b is 4, and c is negative 4. We just need to do b squared minus 4ac to see how many solutions that it has. We aren't going to solve it. So when I plug that in, again, use parentheses. So I'd have 4 in for b, 4 squared minus 4 times a, which is negative 1, times c, which is negative 4. 4 squared is 16 minus 4 times negative 1 times negative 4, that's 16. And 16 minus 16 is 0. So if the discriminant is 0, that tells us we had one solution, okay? Just one solution. And this process will be the same for the next two. Make sure you put it into standard form first. It has to say equals 0, so I need to add 1 to both sides. Add 1. 6x squared plus 2x plus 1 equals 0. Now we'll label a, b, and c. A is 6. B is equal to 2, and c is equal to 1. Now we will just plug these values into the discriminant, b squared minus 4ac. b squared minus 4ac. And for b is 2. 2 squared minus 4 times a, which is 6, times c, which is 1. 2 squared is 4, minus 4 times 6 times 1 is 24, and that is equal to negative 20. So it's a negative number for the discriminant. If the discriminant is negative, that means there are no solutions. Well, no real solutions. There are some imaginary ones, but we're not going to touch on that. All right, so no solution here for number 2. Now, lastly, number 3. Got to put it in standard form first, so it has to say equals 0. We have some options here. I think I'm going to keep the 1/2 positive, so I am going to subtract the 7x from both sides, and I'm also going to add 1. So minus 7x plus 1, minus 7x plus 1. Bring them all over. Standard form, 1/2 x squared minus 7x plus 1 equals 0. Got it in standard form. Let's label A. A is 1/2. B is negative 7. C is 1. Putting it into the discriminant, b squared minus 4ac. And for b is negative 7, so I have negative 7 squared minus 4 times a, which is 1/2, times c, which is 1. Simplify it down. 7 squared is 49. Minus 4 times 1/2 is 2. 2 times 1 is 2, so minus 2, it equals 47. That is positive, so there are 2 solutions. And they are both real. And that is all we have for today. Pretty short day. Make sure to practice up on these. Have a good one.